Okay, good morning. Welcome to day 11. I'm starting to lose my voice a little bit, so hopefully we make it through this. I've got my You Can Do It Celeste mug full of warm tea, so hopefully it's cooled off just enough. I can drink it by the time my voice starts giving out. But let's get it done, huh? Oh, what a rough day yesterday was. Thanks for sticking through that, everybody that did. All right, plain lands. By modeling the process people use to choose or abandon their seat in the waiting area, you're pretty sure you can predict the best place to sit. The seat layout fits neatly on a grid. Each position is either floor or a seat, which is an L, or an occupied seat, which is a octothorpe. For example, the initial seat layout might look like this. Now, you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats adjacent to a given seat. One of the 8 positions immediately up, down, left, right, or diagonal. The following rules are applied to every seat simultaneously. I feel like that could be a trick here, depending on what they want from us. If a seat is empty and there are no occupied seats adjacent to it, the seat becomes occupied. If a seat is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Otherwise, the seat state does not change. Floor never changes. Seats don't move and nobody sits on the floor. Okay? After one round of these rules, every seat in the example layout becomes occupied, okay, because none of them were occupied at the beginning. Oh, I see. So it wants us to check these all at the same time, so like we don't fill from the top, and then like that doesn't influence the choice of another seat, whether it gets filled. It's either filled all at once, or all of the rules happen to all the seats at the same time. So you can't modify your seat map as it's happening. After a second round, the seats with 4 or more occupied adjacent seats become empty. Okay. The seats with 4 or more occupied adjacent seats become empty. Again, I'm assuming this applies all at once. And in this case, this one doesn't become empty because there's only 2 next to it. So, and then same thing. Wait. This one only has 3. It is one of the 4 seats in that little cluster. Okay. This process continues for 3 more rounds. Boop, boop, boop. At this point, something interesting happens. The chaos stabilizes, and further applications of these rules cause no seats to change state. Once people stop moving around, you can count 37 occupied seats. Simulate your seat changing area by applying the seating rules repeatedly until no seats change state. How many seats end up occupied? Cool. Okay. So first things first, I'm going to use their sample seating map. And then I can't remember if I made a thing for that. Nope, just ints. Okay. That component separated by a new line. So that'll get us the rows. And then what we want to do is turn this into an array of arrays. And then I want to try to print it out to make sure that we can visualize this accurately as we go. So that's an array of strings, and then I want to map an array from each string. So this becomes an array of arrays. Okay, and then I'm just kind of curious what the default print looks like. If it's not nice, I'll just write another one really quick. My guess is it's going to be ugly. Yeah, yuck. Okay. Let's see. Let's do an extension on array where element is string dot element. I cannot remember. Is it that? String non-protocol non-class string element, aka character, where element equals. Okay, cool. And then we're gonna say we're gonna func print, and it's going to print itself out. So what it's going to do is so it's going to say for row in self let string equals row dot not compact map reduce. I can never remember the name of reduce. Initial results empty, and partial string in. And then what we're going to do is we're going to return partial plus space plus string, I think. And then we're going to say, is it happy about that? I don't know if I got the syntax right on that. Cannot convert by. Okay, we're fine. Okay, happy there. Okay, and then so that'll get us the string for one row. So that basically gets us a nicely printed row. And then let's see if our string equals this. We're going to string plus equals this plus a new line character, and then we're going to print string. Is that all valid? Refers to an instance method rather than global function. Do I have to Swift up print? Okay, there you go. Cool, and then we're gonna do rows.print. So this should get us a nice, neatly printed. Hey, look at that. I don't even need the spaces between them. So let's ditch that. Okay, cool. So we got a nicely printed out thing. So now the rules are, let's steal these rules really quick because we're going to be referring to them. Okay. So for a given seat, if a seat is empty, okay, so we're going to do for y in rows.count, for x in rows.count, and then is it going to be one of those kind of mornings where my brain don't work good? So we already know that we can't modify this as we go, so we're going to want to copy at some point, but I'm just going to try to get the logic down. Okay, so it says if rows sub y sub x equals L. Let's see. I think we're going to refer to this a couple times, so I'm just going to do that. If space, not C, because some of these will not be. If space equals L. Okay, if it's an empty seat and there are no occupied seats adjacent to it. Okay, so now we need to, wow, yep, it is going to be one of those days, huh? The seat becomes occupied and no adjacent. That's going to take some code. So we'll figure that out in a second. If a seat is occupied and okay, so L, oh man, it's going to be mad at me until I just do this. Okay. Else if space is octothorpe and 4 adjacent seats are occupied, the seat becomes empty. Otherwise, the seat state does not change. Okay, that's it. No, so we don't have to do anything for the periods. Okay. We're gonna do, what was this again? This is an array of string elements. I guess I can just copy my extension declaration. I'm not gonna make this a global declaration because I don't think that this particular check will be useful in future days. If it is, I can update it and make it more public. Okay. So what I want to do is I want to say func number adjacent where number adjacent to x, y, where character, and it's going to return an int. So it's going to count the number of spaces adjacent where a character is a given thing. So let's just count them. And then we're going to return the count. So if self sub y sub x, we're going to do -1, but we're going to do the minuses first because they're easier. If x minus 1 is greater than or equal to 0 and equals character, count plus equals 1. If y, I can basically just copy this, no need to retype. If y -1, y -1, and then just x. So this is same thing. So we're looking left and we're looking up, and then we've got to look left and up. So we're going to do and y -1 is greater than or equal to 0, and both of them are -1. Okay, so that's, let's label these really quick. We're going to check left, up, upper left, and then we can basically just repeat this whole thing, or this is going to be right. So this is +1 and this is +1, and instead of checking, we want to make sure that it is less than self. We know that they're straight edges, so we can just pick a random one to check the count, because we're just trying to make sure that we don't run off the right side. And then, so x plus 1, perfect, and that is right. And then y plus 1 is less than self.count. Again, so this is making sure we don't run off the bottom of the rows. That's down. So left up, so we've got the 3 left up, left directions. We've got right down, and then lower left. So we're going to do plus 1 is less than self.sub0.count, and y plus 1 is less than self.count, and then change these both to pluses. Okay, so now we just need, so we've got up, down, left, right, and then we've got upper left and lower right. So now we just need the inverse 2, which is going to be, let's see, we did upper left, so this needs to be, actually I should copy this one for upper right, because that's probably got more in common. Upper right would be x plus 1 is less than self sub0.count, and then negative y still, so we just changed the x there, and then we need lower right. We got, wait, this is lower right, this is not lower left, we need lower left. Lower left would be x minus 1. It's greater than or equal to 0, and lower would be down. Perfect. So this one just needs to be changed to a minus, and then we return the count. So let's the rules were, I totally pushed the rules off the screen by adding these. Okay, so let's get back to our working code here. And there are no occupied seats adjacent to it. Okay, so let's print out rows dot number adjacent to x, y, where the character is occupied. Let's just do that really quick and make sure it's got the top. Okay, it should always be 0. We know that because it starts with nobody. So I guess what we can do is we can actually and equals 0. Then that's when we need to become occupied. And then and rows dot number adjacent to x, y, where character, this is the octothorpe. Let's see, if a seat is occupied and 4 or more greater, so that's greater than or equal to 4 seats are occupied, the seat becomes empty. Okay. And then what we're going to do, we know we can't modify it as we go. So what we're going to do is we're going to say var copy equals rows, and then we're going to say copy sub y sub x equals occupied seat, and then copy sub y sub x equals empty seat. So that's how they flip states. And then at the end, rows equals copy. So we basically commit our changes and then we print. So let's try this. Okay, that looks like what we were supposed to get. So we're gonna say, okay, so what I'm gonna do is I'm gonna say while true, and I'm going to move that here. And then for iterations, I want to know the number of times I've gone through this. Iterations plus equals 1. Okay, so while true, if rows equals copy, rows dot, well, actually, either way, I want, yeah. We're going to copy dot print and break. Otherwise, we're going to rows equals copy for the next pass through. So this is, are we done? Now, hopefully it doesn't. Okay, it looks like it ended very quickly. How many iterations did it say? After this process continues for 3. So 1, 2, 3, 4, 5 iterations. And then once we get to the end, I want to print iterations run. 6. Okay. At this point, something interesting happens. The chaos stabilizes. So once people stop moving around, you count 37 occupied seats. Simulate your seating by applying the seating rules repeatedly until... okay. So then what we want to do is we want to say func total character, and it's going to return a number, so we're just going to count them. For row in self, for character in row, if character equals character total plus equals 1. And then we're going to return total, and we're going to print the total occupied seats. We don't want iterations. We want to print rows dot total of occupied seats. 37. Okay, let's do some real puzzle input. Unsurprisingly, the seating chart is unbelievably big. It wouldn't be interesting if it was small. Okay. Let's see. Fatal error. Uh-oh. Rows sub-0 dot count. That's a little mistake. Okay. 2,424. Cool. What's part 2? As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seats. They care about the first seat they can see in each of those 8 directions. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of those 8 directions. For example, the empty seat below would see 8 occupied seats. The empty seat below, for example, the empty seat in this chart would see 8 occupied seats. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So would see 8 occupied seats. The leftmost empty seat would only see one empty seat? Would see 8 occupied seats, would only see one empty seat, but cannot see any of the occupied ones. The empty seat below would see no occupied seats. Okay. Also, people seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty, rather than 4 or more from the previous rules. The other rules still apply. Empty seats that see no occupied seats become occupied. Seats matching no rule don't change, and floor never changes. Given the same starting layout as above, these new rules cause the seating shift. Okay, so this is going to be a bit different. Okay. So instead of counting a number adjacent to, we're counting a number visible to. Visible to. So let's see. I'm commenting out these ones because these are the hardest ones. I think basically all you do is you just turn each of these into a loop and then you're done. And then you stop as soon as you see a seat. So those are the two things. Where character see through the character. So that's where I'm going to pass in the period. I guess it's always going to be period, so I don't need a parameter there. Okay, so for example, in this input, I'm going to use all these sample inputs because I think that they are good little test cases. So what we're going to do here is number visible to. So it's always looking for the L. It's always looking for the empty seat, and it is always. Let me reread the rules really quick. They care about the first seat they see. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in the line of sight. The leftmost empty seat below could only be one seat. Okay. So what I want to do from this one is I want to walk in a line until I hit something that's not a period. And if it's that, then we increment the count. So in these kind of situations, there we go. In these kind of situations, I think it's best to just take them one at a time. So what I'm going to do, I'm just going to take that, walk to the left. So what we're going to do is we're going to say while, let's see, var x index equals x, var y index equals y, while x index basically this, while x index is greater than or equal to 0, if var target space equals self sub y, come on keyboard, play nice, sub x minus sub x index, if target space equals a period, then we continue. Just for legibility, actually, I'm going to do this because we say else if target space equals the character we're looking for, then count plus equals 1. Otherwise, we give up because we hit something. And then this is x index plus equals 1. I don't know what the heck I thought that was supposed to be. Yeah, there we go. Okay, so, and y-index never changed in this case, but it will change in the future cases. So in this case, we're just walking left. So let's actually start with this one as the input, because it actually has hits in all directions. And we're going to say, I'm going to rearrange these really quick so that my scroll distance isn't quite so far. Okay, so this is part 1. And then what I'm going to do is I'm going to say part 2, and we're just going to say, okay, how many are visible? So in the case of our input, it is 0, 1, 2, 0, 1, 2, 3, and then 0, 1, 2, 3, 4. 3 and 4, huh? Okay. Okay, so what we want to do is we're going to say rows dot number visible to 3, 4, and I'm looking for hashtags. We're going to print this. Nothing's visible. Did I not increment the count right? What did I do wrong here? Count equals 0. Okay, let's just step into it. I'm sure I did something wrong. What is target space? Oh, that's not right. That's already, yeah, because of course the target space -1. Let's try that now. This 1, okay, because we only walked left. Okay. Now, basically, this this whole thing can be reused. So we're now going to replace the right and it's going to be +1, and then this is the same. Well, x index is less than that, and then x index is supposed to be -=1. It's walking left. And then we're going to do the same thing. Y index, or sorry, x index, we're walking right this time. So x index +1, x index plus equals 1. We're walking right. Okay, so let's run it again. It should now be 2. It is. So hit this one and this one. And then this is I'm kind of seeing the pattern here. Okay. This can go. So the pattern here is that this is just like marching in a direction. So what I want to do is I want to do first character in direction X, Y, where these are going to be changes in X and Y, and this is going to be a character. And then basically what we actually want here is we're going to, and then XY and then DX dy. Okay, X plus dx, y, d is delta, so change in x, change in y. So in this case, if we wanted to march left, we just pass a -1 and a 0. And so then what we want to do is, well, x index is less than that, and x, so we're going to do all the checks, and x index is greater than or equal to 0, and y index is greater than or equal to 0, and y index, index is less than self.count. If well, those are all true, then what we're going to say, if target's, then x index plus equals dx, y index plus equals dy, and then if target space, so otherwise we're going until we hit something, right? So otherwise we actually are just going to return target space, and then in this case, return error, exclamation point, assert false. We should never get here. Okay, so let's try this with our left. So we've basically taken this and generalized it. So now we should be able to say, let's see, left equals self.first character in direction, so x, y, -1, 0. And then the left, we're going to say if left equals character, then count plus equals 1. And then that should get us the exact same results. Yeah, let's kill right for a second. Gets us 1, perfect. Okay, so let's start chopping stuff up. Left, right, right, and right is just +1, and if right equals the character, then we keep going. 2, left and right. Okay, feeling confident enough that I'm just going to cruise through and do all of these. So up would be 0, 0 and -1 for the y, and this is up. And then down is going to be this. So this is down, and this is down. Okay, so this should hit 4. This only hit 2. Let's make sure that my loop is doing up and down right. Let's go like that. I'm going to step into it. dx 0 dy, target space is L. Oh, am I handing it the wrong space? 3, 4. 0, 1, 2, 3, 4. Oh, duh. Y index. There we go. That should fix it. So that should be 4. Okay, simple enough. And then, what did I just delete? That was not what I wanted to delete. Okay, so now this is the first interesting one where upper left is up and left combined. Up left, and it is up. It's -1 on both, and then upright, upright. So that just changes to a plus, and then upright, up left. I guess it doesn't matter which one I do next. We can go down left. Ooh. Down left, down right, I mean, apparently. Down right. So down would be +1, and right would be +1. Down right, and then down left. Down left. Down, and then left. Okay. So then the final output should be 8. Cool. Let's try the other output here. So this one is interesting because you can see two different things. So it is 0, it's 1, 1 in this case. So we're starting at 1, 1. Okay. So what this case is, if target space equals is a space, else if target space equals, oh wait, hold on, how did we get here? Target space. Oh, first character in direction. So I guess this actually can be optional, huh? I'm not thinking about this clearly, because you, like, obviously you can run off the end of the board and stuff. So, let's, I don't know what part 1's doing right now, and I don't want it to mess with it. I do want rows though. 0, okay. So, let's see. We wanted it to find the L. Oh, and I asked it to find the hashtag, which it doesn't find any. Let's see if it finds the L. It finds 1. Okay, cool. It doesn't find any hashtags. This one should find no hashtags and no L's. So 0, 1, 2, 3, 0, 1, 2, 3. So 3, 3, and I'm looking for L's or hashtags. And both should come up empty-handed. 0, Octothorpe, 0. Okay, I think it's working. It feels like it's working. So let's go back to this. And so let's reread the expectations really quick. The new rules, okay. people seem to be more tolerant. It now takes 5 or more visible occupied seats for an occupied seat to become empty. Okay. So we're basically going to do this whole thing again. We're going to say while, actually, I'm going to just copy this, I think, and then recomment it out here, because they actually mess with each other. They modify rows. Okay. I don't care about iterations. Okay, so what I want to do is I want to say go through each seat, get the space there. Let's see. Let's reread the rules now. Now, instead of considering just the 8 immediate, for example, the 8 occupied seats, the leftmost empty seat would only see 1 seat available, but cannot see the occupied seats. The empty seat below would seem occupied. Also, people seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty. Okay. And then we're going to say rows dot number visible to x, y, where the character is hashtag. Okay, so if the occupied, then it becomes empty. Occupancy rather than 4 or more. Greater than or equal to 5. Takes 5 or more visible. The other rules still apply. Empty seats that see no occupied seats become occupied. Okay, L, and then, okay, why did I just do all of that? I just like completely flipped my thing. That number visible to x, y, if it sees, if it's greater than or equal to 5, and if this one is number visible to x, y, looking for octothorpes, then it becomes occupied. Okay. We don't need this anymore. And I'm still, again, at this point, people stop shifting around. 26. 26. Okay, let's get our puzzle input. Puzzle input. See if it explodes on me. Ooh, look at all those iterations. 2208. Gold star. Cool. So let's talk about the solution really quick. Let's see. We're going to do let input, and then we're going to do var rows equals input, and then we're going to do this really quick, and then we're going to, up here, we're going to say rows equals input, and then we're going to turn off our prints so that we can see nice, clean responses to both parts. Okay. Uh-oh, what did I break? Oh, parsed. So we should get 2424 and then 2208. Cool. Okay, so let's talk about the solution here really quick. I think this is a lot more straightforward than yesterday, so not nearly as complicated. There's probably actually something I could have done here to simplify this and turn it into something more like this. I just didn't. It was so straightforward as I was cruising along. It's like 2 lines of code per thing. So I didn't do anything. Okay, so part one, if you weren't following, is pretty simple. We know it's always going to end, so it's pretty safe to use a while true there. I was counting the iterations. We don't need the iterations, so let's clean up stuff that we don't need. Remember, we brought this up at the beginning. You have to copy it because all of the operations have to happen at once, and so you have to read from the existing data, write it to some new data, and then once you're done, then commit it all at once. So that's what we're copying here. And then this is pretty simple. We're just going through literally every column, every row, and we are checking and saying, okay, does it meet the adjacency rules? And if so, then update it. So maybe it's a few lines of code, but it's not complicated code. And then at the end is if nothing has changed, then we're done. Otherwise, commit our changes and move on. So same thing here. This is basically the exact same logic. The only difference is we're doing number visible. So and we had to, because we were committing it, we commit our changes as we go. We just had to make a fresh copy of our rows back to the initial input. So they're the same. And then the only difference here is, do you look at one directly adjacent, or do you loop over it and just keep checking in the direction until you hit something or run off the end of the board? So that's it. Okay. Well, hopefully you learned something there today. Hopefully you're feeling more confident about tackling Advent of Code. And if you like these, make sure you like and subscribe. It helps the channel grow. Also, catch us tomorrow. We'll be doing every single day until Advent hits. All right. Check you next time. See ya.